My name is John Gruber. I'm a global architect with F5 Networks. We have built an LBaaS plugin, and we thought we'd share with the community our experience walking along the way and maybe a cautionary tale about some of the things that are going on inside of OpenStack Neutron. So we'll go to our presentation. We have a couple quotes here just to show that these are not new topics. First of all, a name we all recognized at the top made a statement about SDN. He said, SDN is a mechanism, network virtualization is a solution. And then we have a definition from 2006 of what network virtualization was supposed to be. And that was taking the weight off of somebody to run a network and allowing them to have it dynamically provisioned. So before, we did a good job when Neutron was originally defined. We have a bunch of policy elements out there in the network, and we created this store called Neutron, and we sunk all that data into it. And then we noticed that it looked rather monolithic. So what did the OpenStack community do? Well, it changed it from a solution to a solution that'll work with multiple people. Sorry, that obviously didn't font very well. But you'll notice we added extensions to it. You see those things that say provider net extensions down there at the bottom? That provides meaningful data for someone who's doing an integration into a network fabric. It tells them what kind of L2 network they're talking to, what the segmentation ID, those things. We created other extensions like the router extension, which means this is a globally routed thing. Routing is external to the SDN we'd be talking to. We are now officially saying you got to be ML2. We said here are the network types we're going to support. You'll notice local flat, VLAN, GRA, VXLAN. And when we made those type definitions, we're really getting on the road to the point where we can start to deploy network virtualized tenants and do them right. Now, if you look at what that meant for other services, it wasn't just L2. There were L3 dependencies, and these really came over from making sure it worked with the VMs. You saw things like the DHCP agent, which allows us to make sure that our guest instances get IP allocations. You also saw things like the L3 agents, which perform NAT and SNATs on the part of VMs to get off of the SDN and to be able to let it talk at layer 3 into the regular network. I haven't told you anything you don't know already. But this architecture was struck by the community, and it actually worked pretty well. It has both L2 and L3 source of truth in Neutron. That was the data store. Now, when we went to do our integration, it became clear that you really had the tale of two possible integration paths. One of them stuck to the Neutron model. And that means we depended everything we needed for our integration. In our case, it was load balancing as a service, but it could be any advanced service in Neutron. One of them said that data should live inside of Neutron. Neutron was your source of truth. And then we went to deploy it with early customer access, and we found out that not everybody played that way. They took the value out of Neutron, and they made Neutron an API shell above their own controller. Now that is kind of an interesting idea. It may have some merit, but I want you to notice something in this graphic. If you're going to do a meaningful integration to Neutron, you not only have to integrate to Neutron now, but you'll see the blue line there, you also have to integrate to the controller. And that very well may not be open. If that is a proprietary controller and you have to have either a customer agreement or a partner agreement to get to the APIs for that, all of a sudden we have an open network infrastructure where FOSS and other things can integrate well, and then you have a closed network infrastructure. So we're giving a little cautionary tale to the world that's going to integrate to Neutron today. Make sure that the minimal information and the source of truth of all your network integrations is Neutron if you plan on having an OpenStack network. Because otherwise we could allow this all to bleed into proprietary network architectures. So what's possible with our OpenStack network today? Well, a lot of good things. So for instance, this is a typical compute node. We're using OVS. Here's an example of the provider type extensions that says we can use VLANs. Well, good. That opens up the ability for us to use network virtualization with VLANs to connect to existing data center VLANs. You can say that they're a provider VLAN, it's already there, it's a shared network, you can connect to it. It also gives us the ability to say tenants can manage their own VLANs. VLAN IDs are dynamically allocated out of Neutron, and they can be used on your integrated devices. So we can do VLANs. Excellent. What else can we do? Well, this is an SDN capable solution as well. The two SDN solutions for overlay tunnels were GRE and VXLAN. Now, how does that work? Well, the agents have other APIs and other RPC mechanisms to be able to communicate the VTEP tunnel IDs and to be able to say where the various parts of the network need to graft into this SDN network fabric. But is this possible with standard OpenStack networking? Surely it is. Do you have to go to a closed source to do this? No, you don't. And it works. So we get our overlay SDN network solutions as well. So if you started down an integration path, let's talk about the path of least resistance, but also maybe some problems with it. So let's use LBaaS as an example. Let's say I wanted to do an LBaaS solution, and I'm just going to use the data that's provided to me from the LBaaS spec only. No deep integration to anything Neutron, because let's say it has to work with a third party that's closed. Well, what can I do? Well, I do get an IP address assigned to me on my VIP, but you find really wonky looking solutions where the VIP, the monitors, the SNATs, they all came from that one IP address. Well, that's not real world. You can't operationalize that very well. That's a problem. And it's finding to be a very inflexible and frankly unusable solution for LBaaS. So what if you do just a marginal integration into Neutron? Well, okay, we could get past the problems we had, and maybe we reach in and get some fixed IP allocated for SNAT addresses, and we can still do SNAT mode and one arm. We can do this, but again, it's not the richness that is afforded you if you take advantage of what Neutron was supposed to be. So if Neutron's your source of truth, you know what you can do? That. And this is what we've done in our integration for LBaaS. Our LBaaS takes the information associated to Neutron, doesn't just take the pieces that are part of the LBaaS spec, but finds out what Neutron thinks about the rest of the networks around it, puts all of this stuff together as a service definition, and enables the LBaaS element to be hooked to provider VLANs, Tenant network virtualized through VLANs, GRE tunnels through VLANs, and VXLANs. You can do them all at the same time on the same pieces. But how much of that data necessary to provision that actually lives in Neutron? A significant amount of it. If this data is moved to your controller, you got to make proprietary controller calls to be able to get at this data. But what's possible if Neutron lives up to its potential? Deep, meaningful SDN integrations. And we've done one. So if you look at our solution today, it has all of those characteristics. It's fully multi-tenant. It has L2 separation. It has L3 separation. It'll talk to all of those things all at the same time. If you don't want to do SNATs, we can try to be the reverse gateway for you, so you don't have to use a router object even if you don't want to. We'll be the SNAT gateway in various modes. It has various HA modes that you'd expect out of a commercial vendor, right? The thing stays up like you'd expect a commercial load balancer to. It supports all those ML2 network types. The interoperability for the GRE tunnels is with Open vSwitch. That's important, isn't it? Because you want the networking stack on your most prolific network component, your compute node, to be open, or else you'll be paying licensing fees on every single compute node. Well, that could get expensive. Again, what network modes does it work in? All the ones you'd expect a proxy to work in. All of these integrations are possible with Neutron today, as long as we make Neutron the source of truth for the network. Does that make sense to everyone? Good. There's no missing capability in Neutron to make this work. Now let's talk about, it's not perfect, however. Neutron has some issues. Let's talk about some possible issues. Let's say you wanted to use VLANs as your multi-tenant or as your tenant virtualization technology. You want to dynamically provision them. Well, if you tried to do that with a Nova guest today, the way it works is you'd have to go through the integration bridge in OVS. Well, that's going to strip your VLAN tags off. Whoops. I guess that doesn't work very well. So what do you do to support multi-tenancy? Well, if you don't want to change your OVS config, you use GRE tunnels or VXLAN for multi-tenancy. Can you route right through the integration bridge, right through OVS, go right to the VTEPs for the rest of your compute nodes? You can if you can find the data to connect that tunnel mesh. And can you do it? Yeah. No change whatsoever to standard operations on your compute nodes. You can deploy multi-tenant network fabric elements as Nova guest. If you wanted to use VLANs and you were bent on that technology, well, we can show you how to do that too. Today it's a documentation issue with the big caveat with a bunch of exclamation points that say, by the way, we're going to take a VIF from a Nova guest and we're going to swing it off the integration bridge and we're going to place it on a bridge that's capable of sending VLAN tagged frames out of your compute node. Exclamation point, exclamation point, exclamation point. You just lost all your security groups. Exclamation point, exclamation point, exclamation point. Maybe you don't care. Maybe you are using an F5 device, which by its nature is a network firewall anyway. It's default deny anyway. So as a vendor, we don't have too much heartburn over saying you should do this because we know I have a secured device, but you would be using a security group. So we didn't want to have everybody think it's all roses and peaches with where we are in Neutron right now. We have a ways to go to be able to support all these network topologies. But the cautionary tale from us and the adventure we took when we did a full-featured integration with Neutron is make sure Neutron is your source of truth. If you're trying to do multiple vendors inside your network fabric, this becomes even more important. If not, we're going to go right back to this model right here, where we actually had a closed integration model. Does that make sense to everybody? You have an integration to Neutron, yes, but you see that blue line? That's vendor to vendor. That's vendor to vendor. And we'll do it. We're a good vendor. We have partners. We'll do it. But it wouldn't be an open network, as long as everybody knows that. So that was our integration tale of doing a full-featured, deeply integrated LBaaS with Neutron. Are there any questions?